Alright, welcome to SEPAM. Today we are going to be looking at Physics Paper 2, Variant 1, October-November 2024. In this video, we are going to be looking at question 1 to 20, which is the part 1. And then the part 2, we're going to be looking at question 21 to 40. I'm Orisheje Matthew, so take your pen, your biro, and your calculator. Let's walk through this solution as you prepare for your exam. Alright, the major constants you are expected to use in this question paper examination is acceleration due to gravity 9.8. So the total mark is 40 mark. So let's look at it. Question number 1. Which measurement is shown to the nearest millimeter? So what this question is trying to tell you is for you to round up to 3 decimal places. And you know that 1 millimeter is equal to 0.001 meter. So you have to look at which of them is within the range of 3 decimal points. So this one is not, this is not. So this is the only answer, 3 decimal points. Question 2. A rocket travels with the average speed of this. Now, what is the distance traveled by the rocket? So you want to look at distance. Distance is equal to velocity multiplied by time. So the velocity, which is 6 kilometers per second, multiplied by 2 minutes, which is 120 seconds. So second take care of second. So the answer is 720 kilometers. So that is C. So if we go to question 3, question 3 is about the diagram show the vertical force acting on a ball falling through the air. So we have this ball, so you have the air resistance, which is the drag force. So this one is the drag force acting on it. And then you have the weight. And then the acceleration due to gravity A is directed towards the earth and is always constant, which is 9.8 meters per second square. So which rule describe what happened to the resultant force as the ball on the ball? Okay, so remember that when an object is falling, okay, the acceleration is this. So the acceleration does this. So this is the VT graph. So the acceleration actually reduces, okay? It reduces until it gets to the terminal velocity. So this is the terminal velocity. So when it gets to terminal velocity, then start moving with a constant velocity for a long time. So what is going to happen? Acceleration due to the acceleration reduces, and then the resultant force, since acceleration reduces, result is going to have what is ma. So anything, once this reduces, then this also reduces. So the best answer there is A. Okay, this question here, a coconut fall from a palm tree at S that is from this point here, then Y is the point just before it strikes the ground. what is the acceleration of the coconut at S? The acceleration of the coconut at S is, A is always constant, so it's going to be 9.8 meter per second. At that point that it starts falling, the acceleration that will be on it is the same as the acceleration at the point Y. Okay. Then the next one is we have okay. A car is driven round a bend. So this is centripetal force. Okay. What is the direction of the resultant force as it moves? Okay. What is the direction of the resultant force? Okay, on the car as it go round the bend. So if you have this, okay, and then you have a car moving here, this is the linear velocity, then acceleration due to gravity, this one, centripetal force A, add towards the center, and then the centripetal force, the pulling force, also add towards the center of the, and is perpendicular to the path. So the answer to number 5 is it's perpendicular to the motion and towards inside the bend. Okay, so once we have that, we are good to go, right? Now the diagram shows a drawn bridge that is attached to a wall, okay, as shown in this diagram. Now the weight of, we have the weight of the bridge, then we have this tension adding along the cable holding it to the wall. So which arrow show the possible direction for the force for the bridge to be in equilibrium? Okay, so for this bridge to be in equilibrium, so if you look at this, this is going to give us clockwise, and then this one is going to give us anti-clockwise moment. So, and looking at this direction here, the weight going perpendicular, so this one can be resolved vertically like this. So because it's acting at an angle, the value of this is always lower than this. So for you to balance it, the only way for this bridge is you think about this. So the answer here is D. Okay. So let's look at question 7. Question 7. Which equation give, okay, the momentum difference acting on an object? So if we want to calculate the momentum difference acting on an object, so let's see. So the momentum difference acting on an object, so we know that okay, the difference in momentum is equal to the product of the acting, the force, and the time with which it acts. So the answer is D. Which statement about the use of nuclear fuel as energy resource is correct? Is obtained from the sun? No. It has no environmental impact? No. It's disastrous. Nuclear power station do not need turbine? No, they need turbine because you heat up hot water and then the steam is used for turning the generator. So the correct answer here, energy is released by nuclear fusion. Okay. All right, here, question 9, the diagram show an object M being projected from this point here, then it travel to this point with the speed v. So here, what is the kinetic energy? Is half mv square. And then he traveled to this point here, and then what will be the potential energy here? mgh. Then what is the work done in moving it to this place here? That is W. So what will be the energy of this ball at the point Q? Is going to be the initial energy, take away the work done, take away the potential energy. So the leftover energy that is remaining, so we can say K is equal to half mv squared, take away W, take away mgh. So that is the leftover of the energy. So the answer to this is D. So we go to question number 10. Okay, question number 10. Okay, the Sankey diagram for an electric drill. Okay, so an electric drill. That is one thing I want. What is drill used for? Drill basically is used for creating holes. Okay, so if you talk about an electric drill, which one is the useful energy? Is the kinetic energy used for turning the drill bit. Okay, so this is the useful energy. So this is waste, and then the sound made by the drilling machine is also a wasted energy. And so let's see, we are given that the key to the energy is per each slash is 40 joule. So what is the wasted energy shown in the diagram? So let's look at this, take a closer look at this. If you look at this diagram here, the sound is 40 joule. Then the thermal energy, heat produced as the drill is rotating, you have 40, that is 1, 2, 3, 4. So 160 joule. So the total wasted energy, 160 plus 40, that will give us 200 joule. So the answer there is B. Okay. All right. At this point, I just started a new product on the channel, so you can subscribe for personal coaching. So if you want me to assist you and prepare you for the next coming examination, you can sign up with this form that is attached to the description. And I also want you to subscribe, comment, like and share this video. So that is a way you can assist what I'm doing here. My plan is to ensure that you succeed in the next exam. Alright, so let's go to question 11. Question 11. Okay, had to do with pressure. Okay. Now, in this very particular question, you have an elephant, okay? All right, and the elephant, so the weight of the elephant is 45,000 Newton. So if you want to calculate the pressure is equal to the force per unit area. The average pressure on the floor due to the elephant foot in contact with it is 34,000 Pascal. So we have 34,000 Pascal. Okay, and then if you use that to divide 45,000, that will give you the total area of the foot of the elephant. So, and the total foot that will give us area for the 4 foot is going to be 1.323, okay, meter square. But you remember that the elephant has 4 feet. So what we'll do is that we'll divide this value by 4, and that will give 0.33 meter square. So that is the answer there. Okay, some air is trapped inside this container with a tight lid here. Then the container is heated strongly, okay, behind a safety screen. The lid is blown off by the increased pressure of air inside the container. What causes the increase in pressure of the air inside the container? So if you look at the option that we are given here, so you discover that if you heat up this container and then the air particle that is here will not increase. It's the same number of air particle, but the only thing is that because of the heat, there's going to be temperature rise, and then when the temperature increases, so temperature rise, and this is going to lead to increase in velocity of the particle of each air, and then this will also lead to a higher rate of collision. So we have what? Higher rate of collision with the wall, which will now cause high pressure. Okay, so if this causes high pressure, so what causes the increase? The major cause of this is the air particle move more quickly. Okay, so they move more quickly. That is the answer to that. Then number 13, hot mug of coffee near a large unheated swimming pool holding, okay, that is 2 times 10 raised to the power 6. So that means 2 million kg of water. And then you have hot mug of coffee. So no matter, so this is just a small cup. No matter how hot it is, and then you put it into the water in a swimming pool. Okay, so you have a water in this big swimming pool here. All right, so which of these statements is correct? If the mug of coffee is tipped into the pool, the coffee will lose more internal energy than the water that the pool gain. So this one here, you know, the internal energy is what? MC delta T, okay, which is the mass of water multiplied by specific capacity multiplied by temperature rise. Now, this mass is very small, but this one is very massive. So the internal energy of the substance depends on its temperature. Then the internal energy of the water in the pool is lower than the internal energy of the mug coffee. So the temperature of the mug coffee fall because external energy decreases. So question 13. Now the major point here is that if we said that a very hot coffee is near a large unheated pool holding this amount of water, which statement is correct? So the temperature of the coffee is going to fall if anyone spills off. So the total internal energy of the coffee fall because the internal energy will decrease because of the decrease in mass that pours into the pool. So let's go to question 14. A student measured the mass of water in open container over time. The container is kept in a warm room. The results are in the table below. So 0, 0, the total mass that was present was this at the beginning. Then after this, the mass reduced by almost 2 point something gram. Then it keep on dropping, keep dropping. Why does the mass of the water reduce? So what is making it to reduce? Okay, so the mass of the water is reducing because the water evaporates. So look at the question, open container. So look at the factors affecting evaporation. We have what? 1, high temperature, so the room is warm. High temperature, the room is warm. Then the presence of wind. Okay, presence of wind. So if wind is blowing, then exposure of surface exposure. Okay, surface exposure. Because in this case, they told you that's why you have an open container. So if you look at all these major factors here, those are the things that contribute to the increase in the rate of evaporation. Number 15. 1 kg block of aluminium require more internal energy to raise the temperature by 1 degree Celsius than 1 kg block of copper will require. So here you have copper. Okay, so assuming you have aluminium and then you have copper. Okay, and then so 1 kg, 1 kg. Okay, and then the temperature of this rise by, when it's heated, 1 degree Celsius, and then the temperature of this rises by 1 degree Celsius. So what is the specific capacity? That is what MC delta T. So that is the amount of heat required to raise the temperature of 1 kg of a substance by 1 degree Celsius. So if the value of the specific capacity of aluminium is more than that of copper, so why is this? Is because aluminium have a higher specific capacity than, because the only variable that is different in this place is the specific capacity of aluminium, which is C, aluminium, is different from the specific capacity of copper. So the mass is the same, temperature is the same, mass is the same, then temperature is the same. So the only thing that is different here is the specific heat capacity. All right, question number 16. block of ice is at the temperature negative 100 degrees Celsius. Energy is supplied at a constant rate. The graph shows how the temperature varies. Alright, so if you look at this, we're going to be, you will observe that by this, so here latent heat is absorbed to convert. So here is ice, here is water, and then here is steam. Okay, so here this is when the ice melts to form water. Okay, and then from this point the water start melting and then finish melting completely and everything become gas. So at which point have the ice completely transformed state to water and all the water completely transformed to steam? So you have ice there and then water at this point. So you have completely changed to water. That is 2-4. So the answer to question 16 is D. Question 17. Water waves are reflected at a plane surface. Which property of the wave, okay, is going to be different? So what we look at, you have a plane surface here. So it can be a brick or whatever. Then you have water wave that is coming. Then on meeting this, it reflected. So we have this. So this is the coming wave, and then this one is a. So if what the only thing that's going to happen is that is the direction of propagation. It will bounce back. Frequency remain the same, speed remain the same, wavelength remain the same because it's the same water. So reflection does not affect frequency, speed, or wavelength. Okay, these factors are only affected when the material moves from one medium to another. Is it the same within the same medium? All right, so question number 18 is have to look at refraction. So you have light ray pass through air and then to glass, and then finally he goes to, so at which point does the light speed decrease? Okay, when it move from air to glass, so the speed reduces here, so it decreases at W. And then when it move from air to glass to water, at this point here, Y, it decreases. Okay, so the speed of light so it's going to decrease at W and Y. So the answer is B18. So let's look at question 19. Okay. Plane wave approach a narrow gap. Which diagram shows the diffraction pattern that will occur? Narrow gap. So it is going to spread around the, so this is it. And then the wavelength, so from here to here, so the wavelength of the wave coming must be almost the same size as the size of the opening. Okay, so and it must be less than or approximately A. So as when diffraction, the spreading of the wave across that will take place. Then question 20. All right. Okay, we have ray of light enter a transparent plastic edge, that is from this point here. Okay, from air and is incident on the lower surface at the critical angle. So if it's come at the critical angle, so it will be transmitted, the refracted ray will be transmitted along the interface, which is this that is shown. The angle of incident I, the angle of refraction R, and the critical angle, which diagram show all of them. So this is the angle of incident, this is the angle of refraction, and then this is the critical angle C. So just look at the diagram. So you have angle of incident, refraction, and critical angle. So we have that. So the correct answer is B. Okay. All right, so we've come to the end of the part 1 video of this solution. So you can scan this, and you can have a discussion with me personally, and join the Super Easy Physics and Mathematics WhatsApp group, and then we can discuss solution and help you achieve the grade and meet expectation as you prepare for the next exam. Okay, stay tuned, and you can link up to the part 2 video. Okay, keep studying. Practice make perfect. So I wish you good luck.